Good morning, everyone. It's now 10 o'clock, so we're going to go ahead and get started with today's webinar while people start to continue to filter in. Today is our last webinar of the 2024 Water Quality Wednesday webinar series. So thank you for joining us today. And if you've been at previous webinars, thank you for joining us then as well. Today's webinar topic is Cascading Waterways. So we will have 3 speakers today to discuss this new and emerging topic for conservation, and I'm very excited to see what they have to say. So before we get started, I'm going to launch a poll here, and this is just for us to gauge who is in the audience today, what your knowledge levels are, just so our speakers can have a little bit of an idea of who they're talking to today. So while we let that poll run, I'm going to go through here and just tell you a little bit about some upcoming programs that our team offers. We have 3 upcoming Certified Livestock Manager webinars. These are a webinar series that we partner with the Ohio Department of Agriculture on bi-monthly to offer CEUs for our Certified Livestock Managers. So our meeting next week on April 1st, from 10 to 11:30 a.m. is going to focus on innovative manure management techniques. We do not yet have a topic for our June webinar, and our August webinar will focus on poultry. So you can register for any or all of those at go.osu.edu/CLM. And today's webinar is brought to you by the OSU Extension Water Quality Team. So this is our map of our coverage area here, going around the region. Our Williams, Fulton, and Lucas County position is currently vacant. So if you're interested in potentially filling that position or our other vacant position, you could reach out to our team. I am Rachel Cochran. I cover Paulding, Defiance, and Van Wert counties. Below in the purple, we have Jocelyn Burt. She covers Auglaize, Mercer, and Allen counties. Moving around to the light blue, we have Paige Garabrandt. She covers Putnam, Hancock, and Hardin counties. Our green counties here, Sandusky, Erie, Seneca, Wyandotte, and Crawford, are currently vacant. So again, if you're interested in that, feel free to contact our team. And then our darker blue-green is Amber Emmons, and she covers Henry Wood and Ottawa counties. You can find out more about our team and our current projects, along with resources and links to our past programming at waterqualityextension.osu.edu. So turning our attention to today's webinar, we have 3 speakers lined up for you today. The first up is going to be Wuhuan Zhang. She is a postdoctoral scholar here at The Ohio State University. Following after Wuhuan is going to be Tim Fulks. He is with the Ohio Department of Agriculture as a conservation engineer. And then rounding out today's webinar is going to be Jessica D'Ambrosio from the Nature Conservancy, and she is the Ohio Agriculture Director. So I'm going to end this poll here, and I'll share the results just so our panelists can see who all is joining us today. So with that, we'll turn it over to Wuhuan. So if you want to go ahead and try to share your screen, we can get that going. Okay, that looks great. Wuhuan, you are muted right now.
Sorry about that. Can you hear me now?
Yes.
Cool. Thank you so much, Rachel. And can you see my shared screen now?
It looks great.
Yeah, the first page of my slides.
Yes.
Okay, thank you so much. Good morning, everyone. I'm Wuhuan, a postdoc scholar from Dr. Lai Yang's group at the Ohio State University. It's my great honor to introduce our monitoring work of the performance for multiple cascading waterways in Ohio agriculture landscapes to you today. The cascading waterway systems are an enhancement of the grassed waterway best management practice that can help farmers manage water on their land more effectively. By combining the erosion control benefits of grassed waterways with water holding capacity benefits of small retention cells, cascading waterways can be a cost-effective way to slow down water, set out the sediments, and also filter nutrients from the storm events. However, few studies exist on the performance monitoring of the cascading waterways. With multiple cascading waterway systems installed in Ohio recently, we got a unique opportunity to study and learn more about the performance of this kind of agriculture best management practices in different locations in Ohio since the summer of 2023. 4 of the cascading waterways were selected for our study currently, and they are in Allen County, Defiance County, Seneca County, and Williams County separately, as shown in the map on the right. We are interested in both the water quantity and the water quality performance of these selected cascading waterways. The water quantity parameters of our research include the water levels, flow rates, and the flow volumes to learn more about the volume reduction after the treatment through the cascading waterways for all the monitored storm events. With the infiltration and evaporation considered. And the water quality parameters we care about include the nutrients, total suspended solids, and isotopes. The stormwater sample collected from our field through the H-flume paired with a ISCO autosampler will be carried back to the OSU water quality lab from our fields for chemical analysis. The figures in this slide shows the types of the equipment which are employed in our field and in our lab. The top one is a H-flume installed in the field to collect the inflow. And the picture at the bottom is the SFA equipment to be used to analyze the nutrients in our lab. The nutrients in the water samples we are interested in include the total phosphorus, total nitrogen, dissolved phosphorus, and the dissolved nitrogen. They are tested by the SFA in the Ohio State University Service Testing and Research Lab in Worcester. And the total suspended solids are analyzed through the EPA methods in our lab. And the isotopes in the water samples, the samples will also be carried to Columbus main campus to test the isotope in the water samples for analysis. This slide shows 2 photos taken from our field work. The left one is the Defiance County, the right one is the Seneca County. Both of them show the highest basin at each site, which receives the inflow first during the storm events. Until now, multiple pieces of the equipment have been installed in our field by our team to start the initial monitoring work, including the weather station, Hubble piezometer, and the field cameras. The meter weather station can measure and record the weather information, such as rainfall data, relative humidity, and air temperature. It's also be able to upload the data into our cloud through the data logger here, paired with it, so that we can get the data and information remotely. And the Hubble gives us the data on water temperature and the water pressure in the basins, which we can use and convert into the water volume of each basin to see how it changes over time with the rain events, and then consider the evaporation or infiltration. The field cameras could help catch any potential motions and movements in the field. They are installed in the hope of taking some photos for the storm runoff during our monitored rain events. We also grab samples from all of our sites at least once a month to test them for nutrients and isotopes to further determine the evaporation and the nutrient load that is happening in these basins. This slide shows the flume installation by our group members several weeks ago for storm inflow to monitor the storm inflow at the site of the Seneca County. And this big white thing is 1.5 feet each flume, which will paired with an ISCO ultrasampler to measure the runoff and collect flow-weighted composed samples during the rain events. It's located at the bottom of the highest cell of the Seneca County to collect the runoff to represent the inflow of a storm event. And this wood board, as you can see here, they will work as the wind walls to make sure as much runoff as possible will travel through our flume for our flow volume recording and calculation. This slide shows the field equipment which is used to collect the stormwater samples in more detail. The ISCO automated stormwater monitoring samplers installed at each of the inlets and the outlets of all of our 4 sites to determine the improvements of the stormwater flow and the water quality. And it will work with the H-flume together. And there is also a 730 bobbiner paired with the ISCO auto sampler. This top figure is an ISCO auto sampler with the bobbiner, with the bobbiner and the H-flume to quantify the runoff discharge when the storm is coming. And this set of the equipment could measure the flow rates, water levels, and also collect the flow-weighted composite storm samples for each monitored storm event automatically based on the pacing number we will set before the monitored storm events. There are 24 100 milliliters of the sample bottles sitting inside of the ISCO auto sampler. We couldn't see from this picture since it's inside of the ISCO, but here is a photo to show when we open the ISCO, you will see 24 bottles for the sample collecting. And for this set of the equipment, we will have 8 of them in total in all of our 4 fields. This photo shows the stormwater sample bottles with the flow-weighted composite sample after an event. As you can see, 8 of the bottle has some dirty waters. They are from the storm events. Here are some initial results of our research. The figure presents the daily volume change in these 3 basins of the Defiance County site. We took the volume data of the basins and normalized them as a percentage of the basin's field to be able to compare them more easily. The basin 3 is at the highest elevation, and it's the first cell to receive the inflow during a storm event, while the basin 1 is the lowest cell and the last one to receive the inflow. The yellow bars in the figure indicates the rainfall depth records from May to December of 2023. The left y-axis indicates the percentage of the basin's field. Any line above over the number 1 here indicates that basin is overflowed at that time. And this figure shows the basin 3 tends to be more filled than the basin 1, while the basin 1 only barely overflows once during the monitoring period of the 2023. These results indicate that this cascading waterway system is working as intended to store and reduce water. And the overall runoff leaving the system is significantly decreased after the storm events. This slide shows the 3 retention basins' daily volume changes in our field at Seneca County instead. Similar to the performance of the site at Defiance County in the last slide, the basin 3 of this site also overflows more frequently than another 2 lower basins during last year, while the lowest basin also only overflows once during a 4-inch of the storm event last year, which means the cascading waterway is functioning in storing and reducing the storm event, the storm runoff. As mentioned before, we keep collecting the grab samples from all of our sites at least once a month for water quality analysis, because almost all of the basins are always holding some water. This slide shows an example result for the nutrients concentration responses of all our grab samples taken on November 30th, 2023, across the Allen, Defiance, Seneca, and the Williams counties. This is only a one-time grab sample event showing the ranges of the nutrients concentrations. And now it's hard to see any consistent trend in the nutrients response from it. However, as we get more flow data for the next step, we will know more about the basins, load the nutrients coming, and their functions in treating the chemicals. Also, as we move forward in this coming season, we will get more event-based samples, which will tell us more about this story. For the next step, we will work through the performance data comparing the evaporation to infiltration rates. And until now, we have done the flume installations for Defiance and the Seneca County site. And the flumes for Allen County and the Williams County are designed and will be ready to go out next month. We will also continue monitoring the performance of all of our 4 selected cascading waterway systems during the stormy events. Also, we will have our 5th site at the Fayette County built soon. Once it's done, we will start some initial monitoring for it. I really appreciate all the help and efforts from our amazing group members to make this work possible, and for those field works. And I also thank my supervisor, Dr. Liang, for all of his support and guidance in this great project. Also, special thanks to the support and valuable feedback from PNC and ODA. That's all, and thank you so much. We are happy to answer any questions from our audience at the end of the webinar.
Thank you, Wuhuan. That was great. As she mentioned, yes, we are going to do all Q&A at the end of the webinar. I failed to mention that at the beginning, but from here, if you have any questions for Wuhuan, please go ahead and enter those in the Q&A feature at the bottom of your screen. You should also be able to upvote questions that other people have put into the Q&A. So with that, we'll turn it over to Timothy Fulks here from ODA. And your slides look great, Tim.
Hey, good morning, everybody. Glad to be here today. Again, I'm Tim Fulks. I'm an engineer with ODA's Division of Soil and Water Conservation. I work in Hancock County in Northwest Ohio, and been working on a few of these cascading waterways over the last few years. It's been a fun and interesting change of pace to get to work on these projects. And it's also exciting to be working with Steve's group and TNC to do some monitoring on these to see, what's actually happening with them and help guide us in how we proceed with these in the future. I'm going to get my screen advanced. There we go. I'm going to spend my time today talking a little bit more on the technical aspects of cascading grass waterways. Start out by hitting on a little bit of a traditional grass waterway versus a cascading waterway. What's the difference? Why do we do one versus the other? Then we'll dive into the actual design process a little bit and some of the things we look at there when we're trying to size and install these. Then we'll wrap up by looking at some of the other considerations and challenges we have with these projects. And if we have a little bit of time, I'll probably run through a few slides that highlight some of the projects we have installed so far. So with that, we'll move into the overview here. So I thought it'd be good to start out talking a little bit about what's a typical grass waterway, why do we do a grass waterway, where do we put them? And the purpose of a grass waterway in a traditional sense is primarily to correct gully erosion or prevent gully erosion within a farm field. Places where we have concentrated flow paths going through the field that are eroding the soil away, creating soil loss, gullies that can be issues with farming. And we do that by reshaping that grass waterway to either a traditional parabolic shape, which you see down here in the bottom, or a trapezoidal shape where we've got a flat bottom and side slopes leading into that. So we'll reshape that flow path, we'll vegetate it and get some good dense grass established to help stabilize that soil and prevent that erosion from continuing. So when we design a typical grass waterway, what we're trying to do is create a means to convey a given storm event. So usually we're designing for a 10-year, 24-hour storm event. We'll figure up how big is the watershed, how much flow can we expect based on the characteristics of that watershed. So that includes soil types, cover types within the watershed, drainage, subsurface drainage. We'll look at all those things to try and figure out what's the expected runoff and peak flows from that watershed. And then from there, we'll start looking at what's the proper width, depth, shape, slope of that grass waterway so that we can convey that water without causing additional erosion and also keeping it moving so that we're not getting sedimentation of the sediments coming into that waterway. And that's an important design aspect of a grass waterway. We want to correct the gully erosion that's occurring in the field and prevent additional gully erosion. But whatever flows into that waterway from upstream in the watershed, we want to keep that moving through the waterway. So solids, sediment, silt that are coming into a waterway, ideally, those keep moving through the waterway and exit at the downstream end. Otherwise, we start getting that sediment building up within the waterway, and we'll end up with, we'll lose capacity in that waterway. It won't be able to convey the flow it's supposed to. Water can start pushing outside of the waterway, and we can create erosion again on the outside. So with a waterway, ideally, sediments, nutrients that flow in are also flowing out on the downstream side. And then the last part is it should be compatible with the farming operation, taking into consideration how the fields are farmed, which directions, and making that waterway shape crossable to the extent possible. So keeping a relatively shallow depth compared to the width of that waterway so that our tractors, combines, equipment can all cross those easily. So what are the water quality benefits of a typical grass waterway? Well, to start with, it addresses that sediment loss that we're losing from the gully erosion and preventing future sediment loss from the gully erosion. And on top of that, that's pretty much it. That's what we're striving to do, address that soil loss from the gully erosion, and that's it. You may see a little bit of sediment reduction. Again, that sediment that gets trapped in the waterway, but that's not what we're designing for. We're trying to keep that sediment moving through the waterway so that the waterway doesn't begin to fill in with sediment and create an issue with conveying that flow. You may get a minimal amount of nutrient cycling with the vegetation, but minimal at best. All right, so enter the actual cascading grass waterway. So these, we designed them to convey that flow again, same way we would with a typical grass waterway. We'll design a traditional grass waterway shape that'll convey the predicted runoff and peak flows from the waterway. But then we're going to start adding in pools within the flow path of that waterway to create some additional retention and water quality benefits within that watershed. Before I jump into design, we'll get a little bit of the history on grass waterway or cascading grass waterways. These first kind of came to fruition out in Maryland in the Chesapeake Bay area. They installed the first system out in 2011 with the goal of reducing sediment and nutrients that were being lost from the agricultural landscape into a farm pond and then subsequently into the Chesapeake Bay. So they designed this system, you can see here on the right, at two branches of a waterway coming together into one pond. And they installed 4 cells within each one of those ponds. And along with that, they did complete a 2-year study looking at reductions in runoff volumes, suspended solids, nitrogen and phosphorus. And they did note pretty decent reductions within runoff, within the suspended solids, the nutrients. But kind of the takeaway from that was that those reductions were all mass-based, primarily from the reduction in runoff. So they didn't see big changes in the concentration of your nutrients and your suspended solids. But since they had these pools installed within there, they reduced the total runoff leaving the landscape, and then thus resulting in a reduction in the total mass load leaving the system. The National Fish and Wildlife Foundation did put out a design guidance manual based on their system and their experiences out there. And that's been our primary reference as we've been working these within Ohio. And they also have published a study you can see there on the right that talks about the study they did and the benefits they saw from the Cascading Waterway. Here in Ohio, we started working with these systems around 2018. And I've got listed on there all the ones that I'm aware of that have been installed, primarily here in Northwest Ohio. And I know I may have some of these wrong chronologically in order here. So I know Mercer, Defiance County were right there at the forefront in getting these installed, and Putnam County was right there with them. In 2019, we installed one in Allen County and additional one at Seneca County. And Williams County has been doing quite a few here recently. In addition to that, we've gotten some outside of Northwest Ohio down in the Warren County and Fayette County. So we're getting quite a few within the state here, and it's exciting that we're doing some studying on these now to see what the benefits are, what kind of reductions are we seeing, help guide us as we work on these in the future. So what are the benefits of a cascading grass waterway? Well, they'll correct the gully erosion that we would typically correct with a grass waterway design. We'll have that properly designed cross-section shape and slope going down the flow path to prevent that erosion. But then we're going to add those pool areas in there. So what those pools are going to do is slow the flow of water down through the system and create an opportunity for sediment to drop out. And along with that, any nutrient-bound sediments will also settle out within there as well. And we'll also see reductions in peak flows and runoff volumes at the outlet of the system. So as these pools fill up and then drain back down and capture more water in the future, they provide that reduction in the total runoff coming out of the system. Here in Northwest Ohio, we've seen a lot of these pools don't drain down especially well because of our tight clay soil, but we'll talk a little bit about that here in some future slides. And they'll also provide wildlife habitat benefits within the landscape. So anytime we can pool up water and shallow pools within the landscape, those provide great opportunities for wildlife, good wetland habitat. I can say that in Allen County, these things are definitely frog magnets. All right, we'll talk a little bit about the design process and what we look at when we're designing one of these systems. So to start with, we'll typically just design a normal grass waterway. We'll figure out that watershed size and what the expected runoff volumes and peak flows are going to be, and we'll size that with our normal process. We'll think about whether we want to do a parabolic versus a trapezoidal shape. A trapezoidal shape tends to lean itself a little better towards the cascading waterway system because we have this flat bottom within the cross section of the waterway. That works well with then transitioning into the excavated pool below that. We can make parabolic cross sections shapes work as well. The contractors just have to do a little bit more work to blend that outlet of the pool back into that parabolic shape downstream of the pools. But we can make either work, and we've done both within Ohio here. After we decide on waterway shape, size, and flows, then we're going to start looking at what are our storage goals as far as the volume of water from the watershed. The design manual I mentioned earlier suggests shooting for 0.2 of an inch watershed acre inch of storage. So in practical terms, what that means is that, say you've got a 10-acre watershed draining to your system, you're trying to create storage equal to a depth of 0.2 of an inch over that entire watershed. So this really becomes the challenge we have when designing these systems. 0.2 of an inch doesn't sound like much until you start translating it out across the entire watershed. And that gets to be a pretty large volume of water that we're trying to create that storage volume within a narrow lane of that grass waterway. So if you've got smaller watersheds and longer waterways, it's a little easier to do. But when you start getting into 60, 70 acre watersheds, creating that much storage volume within the Cascading Waterway system gets to be challenging. So 0.2 is what we shoot for. Really, if you can get 1/10 of an inch, any storage is better than none. And we've done some that have been within that 0.14 to 0.16 range as well. But what that means as far as storage within the watershed, if you can store 0.2 of an inch of runoff within that system, let's say you've got a 0.4 of an inch rain event, that may translate into 0.3 of actual runoff, and you're able to capture 0.2 of that and store it all within your system. You can have a pretty significant reduction in the runoff. Okay, so once we've decided on storage volumes for our pools, then we can start looking at how we're going to fit those pools within the waterway system. We could do excavated versus berm pools, or a combination of the both. If you see this graphic here in the bottom left, this is a profile view of the water going through a system, starting here in the top left and flowing to the right. So in this case, this is an excavated pool within the waterway, and we've created all that storage volume simply by excavating this pool area out within the bottom of the waterway. Compare that to the image here on the top right, where we're also excavating, but then we're using some of that dirt to also create a berm and hold back additional water. Here in Ohio, we've worked primarily with excavated pools and kind of shied away from doing bermed pools. We're not too crazy about building berms up within a waterway system that's supposed to convey that water downstream when we get a storm event. This graphic in the bottom right here is a plan view look at a bermed pool system. So you can see we've got the berm here in the middle, but to be able to convey that storm flow around that, we have to build in spillways. So we end up with a wider waterway system. So for everything we've done in Ohio here, we've done just excavated pools, which creates more earthwork to deal with. We'll talk about that a little bit more here as well. As far as the pool top width, if we're doing a trapezoidal waterway, we'll set that pool top width equal to the bottom width of the trapezoidal shape. If we're doing a parabolic shape, we'll set the pool top width equal to about half to 1 to 2/3 of the waterway top width. We don't want to get clear out to the edges of the top width of the waterway system. We want to keep that set within the width of the waterway. The other thing we're going to take a close look at is what's the slope of our waterway profile going down through there. If we've got flatter slopes, it's easier to build in longer pools with excavating less dirt, versus if we have steeper slopes, we end up having to do shorter pool areas so that we're not excavating too much extra earthwork. I've got a few slides here that help demonstrate that idea a little bit. So if you're looking at this profile view of a waterway system, this solid pink line here would be the design profile of our waterway. So this would be the center bottom of a waterway. This lower section is a relatively flat grade at 0.2%. And then here in the upper section, we've got a steeper slope at 1%. When we do an excavated pool, the controlling elevation is that downstream edge of the pool. So that's as deep as we can build water up within that pool. And as we go upstream, you can see we have all this extra earthwork above the shaded blue area that we have to dig out, create extra dirt and earthwork just to get down to this depth where we can actually store water. And on this flatter slope, I can go from station 100 all the way up to almost station 600 before I've created 1 foot of extra depth of spoil that has to be dug out of there. Now, if you compare that to this slope here where we've got a steeper slope at just 1%, I can only run about 100 foot before I've got the same depth of soil over top of that we have to dig out. So if I were to extend this pool here another 200 or 300 feet, we're going to have a lot of earthwork that we have to dig out just to get down to that depth where we have actual storage capacity. So yeah, we like when we have flatter slopes, we can do longer pools, but when they get steeper, we ended up building in shorter pools to minimize that extra earthwork. As we look at the inlet of the pool, where the water is going to flow into it, we'll design rock protection within there to help stabilize that soil and make sure we don't have erosions within there. Typically, we're going to do D or C size riprap, stuff that's 6 to 18 inches in diameter. So some bigger rock, stabilize that. We're going to try and keep that slope on the upstream side of the pool fairly flat to help minimize velocities coming in there and keep that bank stable. On the other design parameters of our pool, on the outlet side, the downstream side of the pool, we'll keep that slope. It can be a little bit steeper, 2 to 1. And then on the pool side slopes, we'll keep those 3 to 1 or flatter. One thing we have to look out for is, do we have concentrated flow paths trying to enter in the side of a pool area? We've had a few of those where a smaller flow path flowing into the side of the pool has started to eat into the side a little bit. So we got to keep an eye out for, if we get concentrated flows coming into the side there. May need to protect that or keep it a little bit flatter to keep those side banks stable as well. As far as spacing these pools out, we shoot for at least 50 feet in between those pools. Provide some space in between there, provide a place for farm equipment to pass in between the pools. All right, so those were the main design things we're going to be looking at when we're putting these on the landscape. I'll talk a few minutes about some of the challenges and issues we've ran into these. Obviously, the first one is if we're doing strictly excavated pools, we end up with a lot of excess soil to deal with. So to give you an example here, if we've got a 25-acre watershed and we're trying to store 0.2 of an acre inch within those pools, every cubic foot of that storage has to translate into dirt that's excavated out of that waterway shape. So just to get that storage, we're going to be at 18,000 cubic feet or roughly 672 cubic yards. That's just to excavate the pools. It doesn't count for the overburden over top of those areas as well. So you'll have that extra soil as you excavate the soil over top of it, and then you're going to have your normal soil that you're excavating to shape the grass waterway. So we end up with lots of dirt to find a home for. If we've got some rolling topography within the landscape, usually it's not too much of a problem to try and get that blended in. In some cases, we've had other practices on site, wetlands or wascobs, where we needed that soil to create dikes or berms and able to use some of it that way. But if you are interested in installing one of these within your farm field, start thinking about a place to put all this extra dirt. The other thing we've run into, and I mentioned this earlier, is that here in Northwest Ohio, at least, we've got a lot of clay soil and they tend to hold water really well. So what we end up with, these pools fill in with water and they stay full for extended periods of time. We end up with saturation on the downstream edge of the pools because those pools are staying full clear near to the top. So that water seeps through the soil, saturates the grass waterway just downstream of the pool, and it can be challenging to establish vegetation in those areas. Those areas stay soft and wetter longer, which can be a challenge for crossing equipment with those. So we'll look at that as we work with these in the future, look at ways to keep those pool elevations maybe drained down just a little bit so we don't get those saturated leading edges downstream of the pools. Actually, out in Maryland, where they installed the first system, one of their concerns was runoff storing in those pools and getting away into the groundwater too quickly. Obviously not a problem we have here in Ohio. We've got the problem of everything sits in the pools too long. And we lose a little bit of that storm reduction capacity if these pools aren't draining down very quickly. So we're losing that benefit if we're not getting that retention gain back within the pools. Another thing we're keeping in mind here is just farm traffic. Is it farmable? Do they have places where they can cross in there, and the safety within those pools existing in the farm landscape? This photo in the right is not a tractor that fell into one of our pools, just a picture I gleaned off the internet, but has been a concern of ours. We want to make sure the folks farming these fields are aware of the pools within the waterway. Consider putting markers, marking flags or stakes out there so it's well defined where those are. And we'll work with the producers to make sure that they can cross in between those pools where they need to. If we need to stabilize some crossings with stone, we can look at that as well. Funding for these. So right now, this is not a practice funded by NRCS. So funding is not available through EQIP or CRP for these, as we don't have a conservation practice standard in place right now. The primary way we've been funding these so far is through Ohio EPA 319 grants, as well as assistance from the Great Lakes Restoration Initiative. To be able to get funding through a 319 grant, you also have to have a 9-element plan in place for the watershed. So that's one of the first steps to be able to secure that funding, is to have that 9-element plan developed, identify those needs within the watershed to have this kind of practice, and then that opens up funding opportunities through Ohio EPA. As far as design and review and approval, since there is no current NRCS practice standard, this practice can't flow through NRCS engineering staff. So we're either working with private engineering staff or ODA's Division of Soil and Water staff can assist with engineering those, so long as we have district partners that are willing to help us with the groundwork, and we can help go through the design and review process and get these designed and put out there. Okay, so that's pretty much it as far as design considerations and some of the other challenges and things we've seen on these. I've got a few more slides here that highlight some of the projects we've done so far. These slides don't cover every single project we've done in Ohio, but we've got most of them here. So here's one we did in Putnam County back in 2018. Watershed was 7 acres, so relatively small watershed for the waterway. We installed 4 pools there, and we were able to hit that 0.2 of a watershed acreage on our storage goals there. In this particular one, we pushed the waterway up along the edge of the field here, along a access lane, and that helped get it out of the middle of the field, so it was less of an issue farming around it. Here's one that was installed in Defiance County. I believe it was put in 2018, actually. It has 3 branches, maybe hard to see here, but we've got a branch here on the left with 2 pools, a branch here in the middle with a single pool, and then another branch here on the right side with 3 additional pools. Total watershed going to all 3 branches was 9.8 acres, so roughly 3 to 4 acres per branch. So relatively small watersheds again. We were able to get decent storage volume compared to the watershed in this one again, 0.21 watershed acre inch. And this one was also funded by EPA 319 funding. 2019, we installed one in Allen County, and I believe this one probably has the biggest watershed of all the ones we've done so far. So it's got a 70-acre watershed. We installed 4 pools. Maybe hard to get a sense of a scale in these, but these 2 bottom pools here at the downstream end are very long, large pools. And despite having some longer, large pools, we are still only able to come up with 0.16 watershed acre inch in this particular case because we had such a big watershed. And we excavated a mountain of dirt out of this one. Luckily, they were able to blend it in nicely back with the landscape on the downstream end, but it was a lot of dirt to contend with. Here's one we did in 2019 in Seneca County at the Soil and Water District owned farmland they have out there. This was an interesting one as we were able to install a number of different practices on site. So if you can see, let's look at the picture on the right. We've got a water and sediment control basin here on the left side. We've got a branch of the waterway here that has our 3 cascading pools. We had a traditional grass waterway here on the right side. Then it all joined together downstream into a traditional waterway again. Then it outletted into a diked wetland cell we created here down at the bottom end. So small little wetland cell. We created a dike here at this end to back that water up. And that dike here and the wascob over here gave us a place where we could use some of that excavated soil from the cascading pools and find a home for it and a use for it. Again, EPA 319 funding for that one, and we were able to get a decent amount of storage within those pools. Here's one of the 2 projects in Williams County that have been installed to date. This one's got 35 acres. I've got 4 pools listed here because that's what we designed for. I think in the end, they actually ended up with 3 pools and 2 of them got combined. The storage volume goal there was 0.16 watershed acre inch. And again, this was another one where we had a diked wetland on site that we were able to use some of that spoil from. Another interesting thing we did with this project is this picture here in the bottom right is the outlet structure for our grass waterway into a ditch there along the turnpike. And we had some challenges with fiber optic in sight, and we didn't want to excavate down too deep to use a normal rock chute, which would have 18 to 24 inch depth of stone that we'd have to excavate for. So we use what they call InstaTurf, which looks a lot like AstroTurf, but it's a manufactured product that you lay within that shape you excavate. You lay it in there, you stake it in place really well, and then you go ahead and seed it like you would a normal grass waterway, and you get a good stand of vegetation that grows right up through it that helps lock it all into place. And they're cost effective, and so far this one's held up pretty well, so we're going to keep those in mind as we look at alternatives to rock riprap chutes. Here's the other one in Williams County that's been installed. This is actually downstream of a existing wetland. So water flows through the wetland. After that, it enters this waterway system downstream, flows through 3 pools there, and fairly decent watershed on this one, 47 acres, but we're still able to come up with decent pools within here and get 0.2 of a watershed acre inch storage on that one. And the last one I'll hit on here today is a project that we just got installed in Warren County. I think Tanner's on the phone from Warren County, and he helped with a lot of the design and getting this one installed. This site as well had a lot of different practices going on. We had a traditional waterway, we had a pipe drop structure, so some different things going on there. But for the actual Cascading Waterway, we had a smaller watershed at 9.6 acres. We dug in 4 pools on that one, and we're able to get some decent storage on this site as well. And that is all I have for you folks. I appreciate the time today. We'll take questions at the end, I believe, but think about any questions. I'll be able to be happy to answer any at the end.
Thanks, Tim. Appreciate it. That was a really great overview and in-depth at the same time. So looking forward to any questions that you guys have for Tim. Put those in the Q&A, and we will switch over to our last speaker of the day, which is Jessica.
Okay, thank you, everyone. I'm just pulling up my webinar here. Let me get it into presentation mode. Okay, everyone can see that?
Yep, looks good.
Okay, well, my role in this webinar, I'm one of the project partners with Ohio State and with Department of Agriculture. And really, I'm here to talk about how we get these implemented, what some of the necessary partnerships, and talk more about the role that this could play in the landscape. So I changed my title slightly to talk about cascading waterways for multiple benefits. I thought Tim did a nice job of talking about the difference between a normal grass waterway and a cascading waterway, and treating multiple aspects. So, and that's mainly why we became interested in these types of projects, is how can we get multiple resource concerns addressed within the same footprint within our agricultural landscape. So farmers can keep farming, be productive and profitable, and we can address resource concerns like sedimentation, nutrient management, and managing and storing flood flows and rainfall flows. And so for those of you who aren't familiar, the Nature Conservancy is an environmental nonprofit. We're the largest conservation organization in the world. We've got offices in almost all 50 states, and we have offices in more than 70 countries. And I lead our agriculture strategy for Ohio and the Western Lake Erie Basin. And so what that means is we take a look at ways that we could work with multiple partners, collaborate, have strategic partnerships, and get implementation on the ground that benefits both agricultural production, biodiversity, and addressing the impacts of a changing weather or changing climate. Looks like my screen has frozen, so I hope you can still hear me. If not, just jump in here. I'm going to move to my next slide. Okay, looks like I'm frozen here.
They seem to be advancing on our end,
Okay.
Jessica.
All right, I'm back again. Okay, so really how this rolls into one of our interest area is we look at agricultural fields from a big systems perspective. So from what's happening in the field to agricultural production to the edge of field to beyond the field. And so a few years ago, the Nature Conservancy developed with a lot of partners an edge of field, leading at the edge strategy and roadmap. And we're really hitting the gas pedal on that and accelerating the principles in that document. And you can go find that document at nature.org/edge of field. But essentially what that document says is, how do we build the economic case for practices at the edge of field that can handle both nutrient management, habitat, and water storage capacity, water management, water transport? How do we increase the capacity to implement those practices? And then how do we elevate a culture of conservation? And again, to do all that, it really takes a partnership. And I like the way this webinar came together because each of our speakers today really illustrates what's needed for those partnerships. And it's really the public and private partners working together to get technology on the ground. And especially when we have something new like a cascading waterway, it really requires a lot of collaboration and partnership and people willing to try something out. And so this is the Allen County project we've brought up a couple of times. That was the first cascading waterway I was involved in. And so as you can see from clockwise or counterclockwise from the top left, that's before we started the construction project, that was the resource concern. This was a waterway that had fallen into disrepair. There weren't a lot of options for the producer to pay to repair it or put it back into place. And so we were able to talk to Ohio EPA, and they were willing to take a look at this project and see if we could fund it, if we did a cascading design. The reason this also came about is, quite frankly, because we had a grant project to do something totally different in a completely different area of Ohio, and that fell apart. So we had a failed project, we had a grant, we had a deadline, and we were scrambling, to be quite honest. And so luckily our funder, Ohio EPA and Great Lakes Restoration Initiative, was willing to be flexible with us and find another location to spend the money and get the benefits that we wanted to get from the original project. And so I reached out to everyone I could think of, and it was the Soil and Water districts I reached out to first, and I said, do you have any projects? Can we do anything? And in Allen County, the technician at the time reached out and said, I've had this waterway. I've been trying to get the landowner to do something for a long, long time. This might be it. And luckily the stars aligned and the landowner was willing to try this. And we were able to make it happen. That's also how the Seneca County project came about. It was part of the same funding source. So I like these aerial photos because it really gives you a perspective of the project. And as we move down to the lower left, you can see during construction and some of the issues that Tim was bringing up about the scale of the project. And what's, some of the things that are necessary, including how we can spoil the material. And it's one of the things we have to think about as we work in agricultural landscapes is making sure that that this is a working landscape and it can be so after we leave the project site. And so minimally disturbing the area that we can when we do spoil material on site, making sure that a crop can grow in it afterwards, and just making sure that trafficability is thought about. And one of the things also I liked about these projects, both the Seneca County project and the Allen County project, was that we also were able to do a little bit of subsurface tile retrofit. So you can see that little berm that's running along the side of the waterway. That's actually the tile main, and we were able to make sure that we could go in and reconnect all the laterals to that main if they weren't connected, and make sure that we were getting as much of that field drained, which is why we had such a large watershed area for this project as we could. Same thing, we did that in Seneca County, where we were able to direct all of the subsurface tile drainage towards that waterway and that project to treat that water as it left the field. So the Allen County project and Seneca project came to us. We needed help. A partner on the ground, Soil and Water District, had a willing landowner or had a demonstration farm. And so that's how those came about. But as we got more comfortable with these things, also around the same time in 2018, 2019, a new tool was coming to Ohio called the Agriculture Conservation Planning Framework Toolbox. And this is basically a GIS-based field scale model that can help you identify edge of field practices and plan for edge of field practices. Gives you a hydro-conditioned data layer. It includes multiple practices within a watershed. You could see the impact of stacked practices together at both the Huck 12 scale and the field scale. And it really can help you when you can overlay it with other data sets like high-risk erodibility areas. You can start to prioritize implementation. So Tim did mention that in order to get some of the funding, you need to have an approved 9-element plan for your Hub 12 watershed. And so what we started to do was work with entities and groups that were undergoing the 9-element planning process with either in-house, the Soil and Water was leading that effort, or they had hired a consulting company like CEC Consultants. And so it was a nice kind of connect together to talk about planning for water quality, talk about where that could happen, and then bringing in, overlaying a few extra tools to help create those project lists that we need to create, and really appreciate the Soil and Water District staff and also the consultants for being willing to bring in the ACPF data layers into the 9-element planning process so we can find out where these go. And so the next two projects I was involved with were really based on starting with the planning process first, which is how we kind of hope it would happen, going through the planning process, seeing where potential places could be for conservation and implementation, and then the local district staff going and talking to landowners and seeing if they would be willing to do the projects. So the next two projects happened in that way. And those were the Fayette County Cascading Waterway and the Warren County Cascading Waterway that Tim had mentioned. And so it was really nice to kind of do the planning process first and work through it and find a willing landowner. So that's been a really interesting process to go through as well. So this is the Fayette County project. We're just breaking ground on that one right now. So my job is to show pretty pictures as part of this presentation. So this is just an aerial drone this is the upstream part of the project. You could see the resource concern. This project actually is going to end up involving 2 landowners. Even though the county approached just one landowner, the neighbor said, "Hey, I've got some issues and maybe I can jump in on this." And here is his field right here. As we're moving downstream through his field, you can see that there is the resource concern, that gully erosion that Tim had mentioned, and how do we address that right through the middle of the field. So this is a relatively large site. It's about 3,100 linear feet. And luckily the landowners were willing to work together. That really helped a lot. And we were able to sit down and talk through what the resource concerns were. We had many meetings around the table and at the site to really talk about, okay, what can we do to help you address this resource concern? And so the project that we're involved with Ohio State University is actually funded by Ohio Department of Education. It's a Harmful Algal Bloom Research Initiative grant. And so that's the work that Wuhuan and Dr. Steve Lyon are doing to monitor these sites, to see if there's efficacy, to see how we can document the construction, the benefits, the site characteristics, the costs, and talk to people and see what is your experience in designing these, what is your experience in implementing them, and can this help meet some of our water quality and water quantity goals. And creating documents like this, which would be a series of case studies outfitted with all of the characteristics of the project, but also bringing in that water quality data, which is so important. And so our goal here would be to, if the data support it, maybe potentially seeing if this could become an interim practice standard that could have its own funding source, so that we can find ways to repair aging grass waterway systems or implement new ones and get that double benefit of water quantity and water quality. And I'll end it right there because I want to make sure we have enough time for questions. I thank you to our funders and thank you to the landowners who've been willing to work with us on these. It's a leap of faith. It's also a leap of faith for the Soil and Water Conservation Districts and Department of Agriculture to try to design these things when we don't have a lot of information and we're kind of, it's new to the area. And I am filling in today for my colleague, Xiaocheng Lu. He is home recovering with an Achilles surgery. So he was originally supposed to give this talk. And if you'd like to interact with the Nature Conservancy in any way, there are a bunch of links here and I can share my slide deck where you can find us and interact with more of our work. And I'll stop there because I just want to make sure that we have extra time to be able to answer questions and have some discussion.
Perfect. Well, thank you, Jessica. We appreciate you filling in on short notice here. And I do want to get to the questions because we've had quite a couple in-depth questions in the Q&A here. So I know Wuhan answered these in the Q&A by typing the responses, but I do just want to go through them for anybody who missed them while we wait for more questions to be put in the Q&A. So the first one was from Dr. Jackman. He says, do you ever have examples of runoff that enters the system midway down or even towards the end of the system? So if there's a 3-pool system and runoff enters into the last or middle pool from a monitoring perspective, how might that affect things?
I think that's a great question. The field work is never been perfect, but yes, that happens. And what we will do is to install the passive runoff connectors to try and measure the chemistries of the scenes like that. Also, we will monitoring the outlets, which will get all the water coming, which will integrate all the water coming into the waterways. As I said in the presentation, we will have 8 set of the equipment in all of our 4 fields, which means we will monitor both of the inflow and also the outflow of all of our sets.
And is that something that happens a lot, or is that something that really just happens with large scale rain events?
I think definitely just to the large scale of the rain events, since we are according to the design of the water cascading waterways, we are supposed to get or at least most of the inflow from the first cell first.
Okay, cool. And then for the second question, I think we could probably hear from both Wuhan and Tim. So also from Dr. Jackman, he was talking about the levels of the pools. And he mentioned that it really looks like the upstream pool usually has a higher volume than the middle pool, followed by that downstream pool. But could there be a situation where the upstream pool has the least amount of water?
Yeah, I think it really just depends on how that particular watershed is set up. If we've got multiple flow paths entering in along the main branch in different locations, then we try and design around that. And as we go further downstream, build deeper pools, bigger pools where we can, and create more storage volume downstream. For most of the ones I've worked on, it's all been pretty much one main branch without a lot of extra water coming in downstream.
Yeah, Wuhan, anything to add to that?
Agree with that, and of course that could be, but then the waterway would likely be poorly located, like if there was a major inflow along the waterway, but then that probably be its own waterways.
Right, and that makes sense. So the design aspect is definitely important here. One question just came into the Q&A about learning more about the maintenance required. Is there any maintenance required after these waterways are installed? Is there any concern of sediment buildup or the need to dip out those waterway pools?
Yeah, absolutely. Depending on the watershed, farming practices, how much sediment is being lost. Those pools are designed to capture sediment, and given enough time, sediment will start to build up. So I think that's one of the things we want to keep an eye on, but definitely down the road, there could be a need to dip out sediment. And vegetation management within those pools is also important. We want some vegetation in there for the habitat aspect and that type of thing, but we can't have, willows growing up within the waterway, that type of thing. So management of the woody brush needs to be taken into consideration too.
Okay, and have you had, I know some of your waterways that you guys have done research and projects on have been around for about 5 years now. So have you seen any of those older cascading waterways start to develop that type of vegetation or not yet?
Yeah, on some of them, we've seen some of that start to grow up, and yeah, it needs to be managed. And have noticed that they are capturing sediment and starting to fill in a little bit. So it's as we expected.
Okay. One question from the Q&A, are you seeing any early insights into how much water is actually infiltrating down through those pools at those research sites?
I think that's a great question. Definitely, the infiltration will depend on the soil media and the native soil media, and also like the weather there. According to what we saw now from our fields, we found the infiltration is a little bit low, and because the native soil media is more like clay, so that the basins of the cascading waterways do a lot of work to hold and store the water instead of infiltrating it. But we are still in an early term of our research. We will do more analysis and monitoring to see how specific is the infiltration and evaporation happen in our field.
Yeah, and I guess along that same vein, are you seeing any constraints with the types of soil that you have to have in a location to be able to execute this project? I know you mentioned a lot of heavy clays, some silty clays, but are you not able to install these on more sandy soils? What does that look like?
Is that a question for me or for Tim?
I'm just kind of throwing it out to the group.
Okay. Yeah, I would think it will definitely be more helpful if we can put more sandy soil instead of some like clay soil there. But that will depend on the specific design and requirement for the cascading waterways.
Yeah, it would certainly be interesting to see how these perform in different soils. You know, sandy soils and other soils that aren't as stable as our clays may not hold the shape of the pool as well. So we'd have some different considerations there if we need to make slopes flatter, that type of thing. But it's something we look at when we design these. So far, all the ones I've worked on have been on tight clay soils, and we know how to work with that.
I think in that case, we may need to focus a lot on vegetation management to stabilize the site with the root system, if that's the case, but we don't know that yet. That Maryland study, I think they had some more sandier soils, but not maybe more loam than a full-on sand. So there was still a little bit of structure there from my recollection.
Okay. And then this next question that came in, I think is referencing Jessica's last slide. It mentions the $71,000 construction costs, but it said it doesn't look like it included design costs. So can you speak to that aspect of designing this?
Yeah, that's a good catch. And I think that represents a potential barrier to adoption, not just for this type of practice, but for a lot of our edge of field practices. We were fortunate enough that Tim and Justin McBride, Department of Agriculture, was willing on a lot of projects to donate their time, their design engineering time on this. However, the Fayette Waterway, that one we were not so lucky to have their time because they're so busy with the other projects. That we did hire a consulting company, and it probably added another $40,000 to the project cost just for the design work and oversight of the project. So it's a real concern about if we're going to think about getting these to scale. So I think the benefit of us doing this work and finding out the information about construction, about design, and about performance can help soil and water conservation districts do the designs themselves in-house. That can help save some money and help them also understand how to manage and maintain it with the landowner over the long term. And also if we're able to justify this being an approved or an interim NRCS practice, that can also help bring in some design expertise that can save money on implementation.
Yes, I was just going to ask about, the timeline of potentially moving this towards more of a NRCS funded practice. So do you guys think that agencies are moving towards offering this, or do you think they're still kind of hesitant to wait and see what the research says?
I can answer, and then Tim, maybe you can answer from your perspective. So I think there's interest. I think we have NRCS as part of our project team, the monitoring projects and paying attention and giving us advice. Department of Agriculture is obviously part of the projects and giving us advice. So really, if we can make the case from both a design need perspective and a addressing resource concern perspective, I think we can make the case. And so what's the timeline? Our current HABRI funding, the monitoring project will run through 2024. And at that time, we'll kind of, or just before that time, we'll assess the data that Ohio State's gaining and talk to the project partners and see what their needs still are. And I think we'd like to go for additional funding support to continue have a little bit more monitoring, but really take a look at the design specifications we're going to need for Ohio specific practices.
Yeah, I think Jessica hit it pretty well there. There's an interest between ODA and NRCS to look at this practice and see what we can do with it, but we need that monitoring data. We need to work out some design things. Right, yeah, a few years out before we're at a point where we'll have a interim practice standard if we decide that one is justified and we should go down that path.
Okay, I think that's helpful. It seemed like there was a good number of farmers on today's call, so hopefully that, gives them a little bit of insight into this. Transitioning a little bit into the actual sampling of these waterways, question for Wuhuan. How long are you planning on sampling with, your ISCO sampler and all that super in-depth technology? How long is that planned for?
Do you mean for the whole project or just for one event? Okay, for the whole project. I think we have started monitoring and get the grub samples from the May of 2023, and we just finished to build the flumes paired with the ISCO samplers several weeks ago at the Seneca County and Defiance County, and they are now working for the rain event sampling connection. And for the Allen County and Williams County, the flumes for those two counties have been designed by the manufacturer, and we will install them in next month. Once that's done, the monitoring work for those two counties will also be underway. Now we have started to collect the stormwater samples through the ISCO and flume for the Seneca County and Defiance County, and all of the monitoring will last until the end of this project.
Okay. And how do you adapt when you see a big rain event or storms that is coming? Are you able to go in and set the automatic sampler to pull more frequently, or how do you address that?
We will get the information from the forecast, from the weather station online or the weather station we installed in our field. And then we will know if there will be a rain event, of course, especially if it will be a good rain event to sample, since that also depends on the duration time, the rain depths, and the flow rate we can estimate. And then if once we decide that might be a good rain event to sample, we will drive to the counties, the sites, to set the pacing number for all the East Coast, and then drive back to our campers. Once the storm event's done, we will drive to the site again to collect the samples and export the data from the ISCO computer.
Okay, so that sounds like a lot of work on your part.
Yeah, that's enjoyable and very interesting.
Good. Well, there was one thing that I noticed kind of throughout all of your talks with the pictures and describing these waterways about, the number of pools. So I guess I'll pose this question to all of you. Are we seeing that more pools are better, or are we still working on that? What's the thought process behind adding more pools versus less pools?
I think, in my opinion, I think more pools will help to store and reduce more water, but that will definitely depend on the specific consideration and desire for that site. So I guess Tim will give us a more detailed response for the design of the cascading waterways.
Yeah, from the design standpoint, I'm first looking at a total storage goal that I'm trying to hit. And then from there, I'm just trying to fit those pools in to the parameters that I have to work with. Like I talked about earlier, when we have steeper slopes, we're doing more pools that are shorter in length to come up with that volume versus if we have flatter slopes, we can do bigger, longer pools without creating all extra earthwork. So for me, it's a earthwork perspective. Um, I'm not, we're trying to get at least a couple pools in there, but whatever we got to do to meet that storage volume we're shooting for, we'll work with that.
And then from the partnership perspective, if we can meet that design criteria and it's suits the land use and the landowner's needs, that's kind of a win-win. So we also want to make sure the pools don't become too deep. There's still trafficability around them, and that we can hit our design targets while making sure that it's a practical solution.
Right, okay. So Jessica shared with me about the Allen County Cascading Waterway being shared at the Conservation Drainage Network meeting that's coming up. I just posted that in the chat for everyone to see. While we are transitioning here for a moment to pull up our CCA credits, I want to mention for our speakers today, if you are open to attendees reaching out to you with questions, please go ahead and put your email addresses or any contact information into the chat and make sure that you share that with everyone and not just hosts and panelists. If anyone has follow-up questions after today's webinar, right now we are sharing the CCA credits. If you are a certified crop advisor and you have the CCA app on your phone, you can go ahead and just scan that QR code through the app and you will immediately receive your CEUs. If you are a certified crop advisor and you don't have the app, you will need to write down the CEU tracking number, meeting title for today, as well as the meeting date and time, and you can self-report that on the CCA website. If you have any issues with CCA credits, feel free to send me an email and I will put my email in the chat. It's cochran.474@osu.edu. And also I'm going to launch our poll for our certified livestock managers. So if you need CLM credits for today's webinar, go ahead and answer yes on that poll. Otherwise, you don't have to fill out the poll or you can just hit no. But we want to make sure that everybody who needs CEUs for today is able to get them. So with that, we can wait for a couple more questions to pop into the Q&A, but I also had a question for Jessica. So what resources can TNC offer to local farmers who are potentially interested in conservation through cascading waterway practices and even through other practices?
Well, I think the best thing we can offer is we can help bring funding to the table by writing grants, public and private funding, cost share opportunities, and really just awareness of what these practices are. I think the benefit of a project like this, like I mentioned, is really the collaboration that it takes. So we want to work mainly with our soil and water conservation staff on the ground, or our crop advisors, so those trusted advisors to farmers, and help make sure that everybody is aware of what the practice is, how it works, what the requirements are, what the costs are, and how we can implement it. And so one of the ways we do that is by participating in webinars like this and hosting our own, by having field days where you can come and really kick the tires on these things, and really making sure that it's a practice that can work for everybody, and it's practical for farmers as well. So we can, on some of the projects we've worked on, we've been the lead applicant on grant opportunities with the Soil and Water District, and others we've helped the Soil and Water District apply for that funding. And then we've also helped on the back end with some of the tools like ACPF Toolbox to support the 9-element planning process. And that way, that's a way to identify potential locations where these practices can take place. So we're happy to come on to site and talk one-on-one. We're happy to work through the Conservation District to help just bring information and answer questions if there's interest.
Right. And you mentioned, kicking the tires. So I do want to put in a little plug for our we're planning kind of a joint field day with a lot of different groups for this summer at the Proving Ground Farm that was mentioned during today's webinar. That will be held in August. We don't have the final details for it right now, I don't believe. But if you're interested in attending that field day and you want to learn more about it, you can always visit the Water Quality Team website, which again is waterqualityextension.osu.edu, and we will have information on that field day when it comes available. I'm going to switch here from the CCA slide just to our thank you. I do have a few reminders, and then I'll turn it over to our speakers for any closing remarks. So again, we have our team email here on the slide if you are interested in contacting the water quality team. All of our webinars from 2024 and previous years have been recorded, and they are posted on the OSU Agronomy Team YouTube channel. So we have a quick go link here for you to access that. Otherwise, you can just Google OSU Agronomy YouTube and it should pop up under the water quality playlist. And as you exit today's webinar, a Qualtrics survey will pop up. This is to help us understand what went well on our webinar series and what we could improve on, and what topics you're interested in for future webinars. So if you have any feedback on that, please fill out that survey. And I do want to thank everyone for joining us today and thank our speakers. So with that, we'll go in the order that you guys presented today. And if you have any closing remarks, feel free to share those. So Wuhuan, do you have anything?
Thank you so much for hosting this.
Yeah, thank you.
Thanks again for having me. It was nice to talk about it with everybody. If anybody has questions on designs, issues, fitting into the landscape, I'd be more than happy to answer those. My email's in the chat, so that's probably the best way to reach out to me. But thanks again, everyone, for participating today.
Likewise, we appreciate your time and interest in this type of practice and seeing if it could be a fit for you. And I also provided my contact information in the chat and on the slide deck, so we're very accessible. So feel free to reach out and just ask questions.
Perfect. Thank you all so much for joining and providing your expertise for us this morning. And with that, we'll just give everybody their 3 minutes back. So thank you.